Our next section and our last section in Chapter 6 is on standard enthalpy of formation and reaction. Last week we talked about enthalpy and how it was a state function, meaning that it doesn't matter how you go from your initial heat or enthalpy to your final heat of enthalpy. All that matters is the difference in the two. The final conditions minus the initial conditions, the difference between the initial and the final, that's all that matters for state functions. Because enthalpy is a state function, we can say that the change in enthalpy for a reaction is equal to the enthalpy of the final conditions minus the enthalpy of the initial conditions. The final conditions for a chemical reaction are always going to be the products. The initial conditions are always going to associate with reactants. And so for any chemical reaction, we can say that the delta H of reaction, and I'm going to put this little superscript 0 like a degree sign on there, and I'll tell you what that represents in just a bit. The delta H of a reaction is equal to the sum of the number of moles of a product molecule times the enthalpy associated with the formation of that product molecule. And all of these summed up together is going to represent the total enthalpy of the products minus the sum of the number of moles of reactants times the enthalpy of formation of the reactants. Now I know that I wrote a lot of symbols in this equation that are totally brand new, so let's go through and break it down one by one. The delta sign we're good with. You know that that represents the change, that Rxn represents reaction. So this is the change in enthalpy associated with a chemical reaction. This symbol here is pronounced standard. So we would call this delta H standard or delta H of reaction standard. And it represents standard conditions. So it's saying at standard conditions for measuring delta H's, this is what you're going to get. And this is saying that this delta H standard with a little f is the enthalpy of formation. The enthalpy of formation, I'll go ahead and write this definition out because it's a pretty long one, is the change in enthalpy associated with the formation of a compound from elements in their natural state. So what you're going to do here is take the number of any given product, let's say product B, times the enthalpy of formation for that particular molecule, product B. And you're going to take the number of moles of product C times the enthalpy of formation of product C. And you're going to add up all of these for every single product. And then from that sum, you're going to subtract basically the same thing for the reactants. The number of moles of reactant G times the enthalpy of its formation. The number of moles of reactant H times the enthalpy of its formation, and so on. We're going to do examples, so don't worry. Your textbook has a giant table full of delta H of formation values in Appendix 3. And of course, you are not expected to memorize most of them. There are some of them that I want you to know, but for the most part, you don't need to know them. You're going to look them up. I will give you their values when you're taking your test. The delta H of formation values are in Appendix 3. So if you open up your book, I unfortunately don't have a copy of your textbook here with me at home, but if you go back into your book to Appendix 3, open it up, and you're going to see there's a whole bunch of data. There's going to be one column that has chemical names, formulas like H2O, H2O2, H2O2, whatever. And then you're going to have 3 columns. There'll be delta H, delta S, and delta G. So it's an appendix that contains all kinds of data in it, not just delta H of formations, but that's where you're going to find them. Just to make sure that you can locate them correctly, open up your book and look up the delta H of formation for liquid water. Remember I told you last week, I think it was on Friday, states matter. Look up the enthalpy of formation for water. This is the energy associated with the chemical reaction that produces H2O liquid from hydrogen in its natural state, H2, and oxygen in its natural state, O2 gas. And that is negative 285.8 kilojoules per mole. Make sure you can find it. Also look up the enthalpy of formation for O2 gas. The enthalpy of formation of O2 gas, that's going to be the enthalpy associated with producing oxygen gas from elements in its natural state, which is oxygen gas. The enthalpy of formation of producing any element in its natural state is always, by definition, 0. And that's the one thing that I do need you to know on your test. I do need you to know that the enthalpy of formation of a substance in its natural state, of an element in its natural state, is always going to be 0. If you look up the enthalpy of formation for ozone, O3, you'll see it's not 0. That's not the natural state of oxygen. Oxygen's natural state is O2 gas. Okay, so for a general reaction, for a generic overall general reaction, let's say little a plus little b, to produce little d plus little e. So these are the little letters are the coefficients and the big letters are the molecules that are reacting together. The delta H of reaction is calculated by this equation right here, the number of moles of a product, little d, times the enthalpy of formation of molecule D, plus the number of moles of our product, little e, times the enthalpy of formation of little e, minus the number of moles of our reactant, little a, times the enthalpy of formation of our reactant A, plus the number of moles of our reactant B, times the enthalpy of formation of reactant B. It's a lot to write these equations out, but they're really fast to calculate, and we're going to do an example of that.